Data science is a buzzword which is going around the market now, right? So what actually data science is? Data science is probably you can define as combination. I mean, if you want to know more about it, right? You want to extract the meaningful information from data. Either the data can be in the raw format or it can be structured, it can be unstructured format, right? That is what actually data science is. Data science is the process of extracting meaningful insights from raw data, which can be in structured or in unstructured format. Let's get into more detail about data science now in the business perspective, right? So it talks about, I mean, if you have a pretty good knowledge of domain for a given, like probably like can be an automotive industry, can be on in healthcare, it can be on aerospace stuff. If you have a proper domain knowledge and a bit of computer statistical, computer programming language, and some statistical or mathematical basics, you can be a better data science scientist in this domain. So the right data science can be drawn out of all these areas. So probably there are other stuffs like if you have domain knowledge and maths background, you can be a better statistician or a researcher there. And you're very good with computers and maths, you can be a machine learning expert. And if your domain knowledge is strong and you are good at computer science, probably you can be a data processing guy, right? So you can extract whichever data is relevant to those to be processed, right? All these things comes in. It is a traditional which being created by artificial design. So I've got some references for that also. Right? Those things in there. What actually data science is not, right? It's not a piece of software end to end which gives you a overall like an app or web application, but it provides you the insights from the data. Probably it can be a dashboard, it can be the results generated from any sort of like the data, which raw data it has. It gives some insights, can be represented in the form of dashboard or can be something like that, right? So it's not merely about visualization, the stuff's there, but ultimately goes through an entire process of gathering the data, filtering all the important stuff there and all these things, right? It's not more related to academics research, but it is like it's more of providing business solution as of science as of stuff there. Probably data science is maybe being started with the academic research, but it's not restricted to that, right? To justify this point, I would like to provide more business solution rather than academic researches. Right? Those things like that. So taking this bit of introduction from data science, we will move on to the various jargons of data science coming from the history, right? What actually is machine learning? What actually, when it was coined and what are the things that were described in there, right? So taking the history back from there, the jargons, if you see, in 1980s, they focused on algorithms and the amount of data was very limited. As you see, the web applications got into the servers and the central server used to manage the entire data because earlier web applications used to be, or not web application as such, applications used to be standalone and the data would be on their local hard drive. There was no any other central storing systems, right? So that's where it was bit tedious to gather the data. But as and when the web application started in 1980s or whatever, right, they got the data in one place now. And they focused, this researchers, scientists, they were focusing on building the algorithms on to train a model or whatsoever. So with this sort of data, they were looking for machine learning stuff. And predictive analytics are more when the data was gathered more and trying to predict what things are there based on the earlier data patterns, right? They use the algorithm that were developed and applied on large amount of data. Those things were being done in late 90s or the beginning of 90s, right? So another stuff where big data analytics came into in the decade of 2000. which we're focusing on computing on big volume of data as in decades grows, right? The data gathered was eventually growing day and day, right? So that point of time, it started with the big data analytics stuff, right? So probably the data would be in distributed fashion and all those things. They used to gather those and then do some analytics and get some insights from it, right? So now if you see, we have computation power as like huge servers are available, AWS there, Google have come up with its own GPU TensorFlows and all those things, being huge data which has been from the decades we have, as well as the algorithms, efficient algorithms are coming, a large volume of data, that emphasizes, that gives you a curve to another right, another area to explore more and do something in it. That's where in late, I mean 2010 onwards, this field have started very efficiently in the drastical change of software industry have led people to look for data science actually, right? The, this is sort of like background of how things moved from a traditional software or towards the data science, right? Since we have the data now from probably like 80s to 2010 and all those things, you have data. Now what should we do with this data, right? So probably when in the earlier traditional ways or so, we used to maintain handwritten forms and all those things. That used to be done or once it is no use. But now we have electronic data which we can dig in more to understand the patterns there, or probably we can understand the customer's pattern. That's how the data science evolved, right? Clear with this? So these are some of the jargons which we can focus on. So now let's talk about what actually data which was gathered in those decades, right? So let's see what was the data actually. Okay, data is a collection of fact such as number, words, observations, measurements or observation, or even discrete description of things, right? So it can be anything, probably a number, it can be a word or comment or video data. Entire things makes the piece of information is what you can say as data, right? So data can be of, generally you can think of data can be divided into two stuff, qualitative data and quantitative data, right? What do you mean by qualitative data? Qualitative data describes for a given piece of probably something, it describes descriptive information would be that, right? The data which consists of descriptive information is known as your qualitative data. Let's say for an example, I drink coffee every day, right? This is a descriptive information. Now looking at the other type of data, it is quantitative. The numerical part is being explained here. This is, yeah, descriptive information, this is numerical information, right? That is how you can understand actually the data if you wear the glass of data scientist, right? So you can understand how data is being divided into two different classes, qualitative and quantitative. In the quantitative stuff, let's say you will be divided that into discrete and continuous, further divided into these two sections. Discrete give you a counted value of it, and continuous what data gives you a measurable amount of, I mean, the quantity there, right? So for an example, I drink 4 coffees every day is like 4 is your discrete value, the counted value, right? And if you say I drink 80 grams of coffee every day, this is your measurable data. Got it? The difference between these two, the qualitative and the quantitative data, right? That is what the difference between what actually the data and qualitative and quantitative. If you see some information like this, now you can put in the glass of data science and divide that into various stuff. All right. So another stuff where we can look in for data in this fashion in the qualitative branch is at the end people will do in the data science as NLP, natural language processing, right? Whatever the text corpus is being given to you, you try to extract the information from it. Probably like you want to do sentiment analysis, or probably you want to extract some of the keywords from the entire, or you want to do classification of various articles, books into various different sections, probably like sports section, politics, or current trends, new technology. If you want to classify different thousands of books, you just based on the keywords, you can classify them into various stuff. That is what your NLP is, right? It can be other various tasks can be done in NLP, right? The other is quantitative stuff. If you want to look for the end application of it, probably you can try to predict some values from the given stuff here, right? Given this, you can think of loan prediction stuff. You can provide this information to a machine, and probably we can define whether it can get the loan or not, right? That sort of prediction stuff can be done in quantitative data, right? Um, this is what a brief introduction about the data. Let's move on. What are the things which we focus? I just talked about, right? The same thing which we can use for text as well as more in more detail in this area. Right? So the qualitative data and thing is what we can do is, as we know that qualitative data is your descriptive information, we can do a sentiment analysis on this. Sentiment analysis here refers to, right, probably a product is being launched, right? How people are, a movie is launched, how people respond to it, probably based on the movie review rating people give on that. It was a good movie, bad movie, or um, a worse movie, all those things, right? That can be classified into, the given corpus can be classified into negative or positive, right? If people get more positive reviews, it can be listed there in the dashboard, right? That things can be done in the descriptive information. Some of the example has been listed here. Your friend's house is pretty good. These are the keywords which makes it to be positive, right? So pretty good, yeah. Oh, good is a keyword which, or tag which makes it to be positive class, right? Amazon Echo is the best AI assistant, best, right? Those things are the positive polarity keywords, right? So these are the usage of text mining, NLP, or sentiment analysis which we can do on this sort of data. Quantitative data represents some quantities there in that, right? Numerical values or so can be defined in this. Probably you can think of a sales prediction. And when it comes to sales prediction, can be in the Black Friday and all those things, or Thanksgiving and all those things. That point of time, people wants to make their sales higher, and they want to clear their old stocks, right? At that point of time, they can stock in more uh, uh, stuffs using sales prediction. Let's say iPhone 8 or 10 is moving fast in this coming sale. I want to make more profit as Walmart. I'll try to figure out what is the current market need, right? Based on the earlier patterns available. I'll stock in that based on the amount it has been predicted. I'll stock in that money phones into my inventory. Once that is stocked in, I can do a prediction that I can make more profit, right? If the prediction goes very well, and the sales of all iPhone 10 is being at a peak, I can make more profit by predicting that, right? That's how we can think of like predictive analytics can be done on numerical data based on the patterns of purchases from various customers, on sale, on off sale, and all those things. Taking that data, right? These are some of the examples of data and their applications in the various market as such. Okay, right. So we're now covering that, what actually data was, what things can be end used with the data. We'll move on to the next step where we can understand what are the various types of data storage, right? So it can be a structured data, semi-structured data, or unstructured data. right? When I talk about structured data, right, it can be a traditional database, it can be an ERP system or CRM systems. Those have the complete information of each uh, column or can be various fields, right? It is in structured format. You have the entire information there, right? So traditional relational database and oracle database and all those things are referred here as structured database. If you see the semi-structured data files, you can think of like log files or XMLs or all those things. These are semi-structured data. And if you see unstructured data, probably you can think of like Firebase, Facebook, Twitter, and all those things, where you cannot predict that this sort of data would be coming every time. Probably Facebook people can upload the text or can be uploading video, audio, or can be images, GIF, and all those things, right? These are sort of unstructured data for a given stuff there, right? Those things are there for when you consider the type of data on which we can do some processing or analytics process, right? As such, we see we define a problem formulation. We do a problem formulation on which we want to work on. Let's say it can be an image classification or probably predictive analytics. We first define the first thing is foremost thing is to define the problem, clear problem statement, right? Based on that, you try to figure out what would be the outcome for it. So, and what are the basic input data that can be gathered from it, right? Data we need to gather, we need to collect the data, do data visualization to understand more how the patterns looks like when it comes to data understanding. If you got a clear picture of the trends and all the things, right, it will be more helpful to apply which sort of algorithm would be efficient enough, right? That would gives you a curve to do the pre-processing. What sort of pre-processing is needed for it? What sort of pre-processing we can think of on based on the data visualization stuff. Once we do some pre-processing, we feed that model to build a model actually. Once we have done the data is very clean enough to feed into model, we go with this step. And in the model building, let's say you want to do classification, right? This. So what we want to do is we want to do a classification stuff. All right. So we can classification and then we can do prediction, predictive analytics. We can do image processing, right? All things can be taken care based on the sort of problem which we are looking for. Once we define the problem statement, according to that, we did the data preparation using pre-processing. We can have a list of model can be done, and then we'll try to evaluate the model based on the model is built on top of training data, right? And we evaluate the model using test data, right? Every time data is divided into two parts. Either it can be when you build the model, you use training data set, probably in the traditional way. We divide that using 70% here, 30% here, and some point of time we use in between a validation also. In that case, the division would be different, 60, 20, 10, 20, 20, like that, to make it 100% data. These are two different versions of dividing the data, right? So what we do is we evaluate the model based on the test data, and we then, if it is good enough, if it is accepted, we can deploy that to production. Otherwise, we'll fine tune the model with various data parameters, create the model, build using various classification and all those things, and then iterate over to get better results. Once everything is approved, once everything is expected outcomes are generated, that can be deployed onto the production server, right? So every time data is being gathered, it will run the entire process from here to here, and then it deploys there on probably on a dashboard or something like that, right? That is what the entire data analytics process is, right? This is the entire journey of data from a raw data or unstructured data which is no worth of getting information. If we feed them to this pipeline, you get recursively better and better and at the prediction, and then you deploy the product. That is what your entire data analytics process is, right?
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.